Hello, everyone.
Hi.
You can hear me here? Okay.
Yes, we can hear you.
All right.
Professor.
Hello, Rahul.
Good to see you again, Professor.
Good to see you, Rahul. I see many new faces, many old faces. Welcome back to this fall session of CS147. By the way, let me start recording this session, and you all know this is being also live streamed on the YouTube, my channel. And one thing that if you don't have a bandwidth problem or any other concern, please turn on your video webcam, so that I can actually start matching names with the faces. Otherwise, what you can do, you can upload your profile, like your face picture, profile picture onto the Zoom meeting, Zoom account, so that at least I can start relating your names with the face. All right. Okay, so where are we? So how things are going on at your end? Everyone is back at campus, or still doing all online, or what is going on?
A little bit of both.
Both.
It's a combination.
Yep.
2 classes on campus, 4 classes. 2 classes online, 4 classes on campus.
Okay. So Rahul, you are back at campus?
Finally, yes.
Yes, sir.
No more staying up through the night for classes.
So campus is buzzing with students like old days, or it's still kind of low attendance there?
It almost feels like the old days.
Okay, good to know that. Good to know that.
It's just everyone's wearing a mask, but apart from that, it feels like the old days.
Okay, that's nice. Anyone else want to share anything? How was the summer? And how was the pandemic you are dealing with? Hopefully you guys are all okay, family-wise and everything.
It just feels so weird to finally get back to campus again. I mean, after all, it's been what, a year and a half, and I got so used to it, and suddenly going back to campus feel weird instead of staying at home. And just funny experience.
Right. So, okay. All right, let's see what we can do today. What we have. Why don't I start with our Canvas page, a little bit explore on that. By the way, like you probably know that I have this Indian accent, so sometimes it's very hard to kind of follow me. So if you have any doubt, any question, just interrupt me and ask me to repeat things. All right. So that's one challenge you will face in this class. Definitely, my accent is number one. Number two is it's a difficult class. It's a hardware class, and some of you are from my CS47 class. You know how it rolls out this whole hardware concept, and who are was not in my class or have taken that corresponding class from the community college or other universities as such. Concept-wise, it may not match. Maybe you were taught with a different processor and stuff like that. So concept is a little bit different, but make sure to sync up with me, use my office hour as much as possible to make sure you are up to date with this course, all right, concept-wise. So that's the one main important thing I'd like to make sure you all know. The reason is that the one we do that, sorry, just hold on. The one, the hardware courses are very much very processor centric. probably some of you have done assembly programming in x86 platform like Intel processor. Some of you have done on MEMS, maybe some Motorola. Some of you have done ARM. I don't know which colleges takes what courses. And how much depth they go into the hardware part. In my classes, I go pretty deep into the hardware. Like for my classes, assembly language was more like a vehicle to explore the hardware, underlying hardware, and we continue from that concept. So whoever hasn't taken that part yet, I can send you the materials and links to those lecture notes and videos you can watch and front and make yourself accustomed, at least with the concept wise. And also I'll try to make sure I form some study group with some of my students from CS47 in your group so that they can explain things to you better. Okay, all right. That's one definite challenge some of you will probably face, but don't worry, I am there for you to help you and guide you through the whole thing and bring you up to the speed for this class. All right, and I'll expect my older student like Rahul, I see Goman, I see Brian Lu, sorry if I miss any, Matthew Maxim, that's the name. Ricky Huang, that's another name I can relate. Yeah, sorry if I don't remember the other's name as well, but yeah, I think many of you are from my old classes. Please help the others who were not in my classes to make sure they are up to the speed in this course. Okay. Any question for me so far? Anything?
Yes, Professor. Can we form a Discord group so we can have instant communication?
Oh, yeah. You can do whatever group you want to do outside this Canvas. I usually don't poke my nose into those groups because I want you to have a free discussion there and do all sort of discussion about me, my course style, about the course, whatever you want to discuss there. So I don't usually join in those discussion groups. Our class discussion, I expect to like question answer or queries if you have. I'll also like you to post those queries back in the Canvas discussion page so that I can participate, clear up the concept along with the other peers. But Discord group is absolutely fine. You please set up one and just, yeah. I believe there is already one on the Discord group. Every semester student asks me about the Discord, and I think there is one. You can join there. Patricia, you have raised your hand, please. Yeah, what's your question?
I was wondering if there was any place on Canvas where we could send a link to that Discord group, or if we could use the chat just for a bit to send a link.
Yeah, sure. I can turn on the chat for a couple of, yeah, sure. I have to turn on the chat. You can send the Discord link. Yeah. Strong.
Oh, hi, Professor. I'm just asking about the prerequisite proof. So I'm a transfer student from community college. So my unofficial transcript on the SJSU, there's nothing there. So can I just submit my unofficial transcript from my old school?
Oh, you can submit whatever transcript you have from your old school. So you are from which community college?
I went to the College.
Okay, so we have this already a course equivalency established with San Jose State, so that should not be a problem. Just upload your Dianza's transcript.
Yeah, got it. Thank you, sir.
Okay. Anyone have any questions? No. All right. So I think Patricia had sent a link to the Discord. Please make sure note of that. And I'm guaranteeing you I'm not going to join in that group. So be free in that group. All right. Truong, you have any other question? I see your hand is raised again.
Oh, I don't have any more questions. Yeah, I forgot to put that down. Sorry.
Okay, sure. No problem. No problem. So again, like all of you, like for example, Trung, Lena, I'm just picking up some names, Patricia. If you can please turn on your video, or if you can upload your picture on the Zoom account, that would be great for me to relate your name to your face. That will really help me. Thank you. Andy, Korak, Tan. Thank you very much. Yeah, it's good to see some faces. I'm still doing online classes, not back at campus yet. I'm not planning to do that this semester. So yeah, it is great to see the faces over Zoom. Thank you. Okay, all right. Let me share with the first pages. So I hope you guys have already went and visit and see the Canvas page for this course. Let me just try to quickly go through that one once more. Share. Okay, so this is your homepage of the course. And let me start from down. So these are some interesting videos. So whatever we built as a computer, it all starts from sand, okay, from silicon. And these videos actually will show you how a sand is manufactured into a chip, and then from chip to the motherboard to the machine, like a laptop is fabricated and built up. The server is a similar process. Then there are like 3 data center, and you will see how the machines are applied at the end. So the whole story starts from the sand, goes into the data center. So this is our life in 147. Okay, these are optional video, some fun video to watch to know how things process. I would highly recommend you guys to watch this video at your off time. Not really needed for the classwork, but it is a good thing to know the overall picture, a bird's eye view of the whole industry. Next is we have the links to all the modules. We have like 10 modules. Module 10 is basically your Verilog tutorial. So Verilog is a language to describe hardware, like the processor, behavior level or logic gate level, that kind of thing. That's a brand new language for most of you, I believe. So this is some tutorial about that language and how can you learn and pick up that language. Though this class is not about, again, like not about learning Verilog, it is using the Verilog to explore the hardware in details. So that's the part you need to pick up. So this is very important module, and you need it for your projects. And you know the projects are 50% of your overall grade. So you need to do good in a project. Make sure you start on project upfront, like from today, if possible. Other than that, there are these 9 other modules. So we'll go through all this semester module by module. And I would say module 1, 2, 3, 4. These 4 module is, I believe, okay, it is more like a 75% from my CS47 class. So my old student has a edge on this module because they already has come through this module. So this is more like a revisit and reviewing these chapters for them. For others, it's a brand new thing. So it's kind of making sure you are up to the speed with rest of the class. So make sure you go through, all of you, not only my veteran student, but all of you go through this basic 4 module, which describes and links between your CS47 study to here. And then module 5 is the one where the fun begins. So this is where we start really on the 147, is a processor design, how we can build up a processor. And then from there, we'll go with the performance measurement. Then we try to see how we can improve performance runtime on the processor. How can we make the processor speedier? And one of them is a pipeline architecture. We'll see some of the parallel processing architecture, review them. And last but not the least is the memory system. This is another system outside the processor and some inside the processor. We'll see that. But this memory system, we need to discuss it separately than the processing system. If you recall, like your computer system study, your computer system can be modeled very simplistically with two components. One is processor, other is memory, and that's it. Any computer is basically that, a processor and a memory. Everything else is a peripheral connected to these two systems, and they're nothing but manifestation of your content inside your memory. So we will focusing on that simplistic model, a processor and a memory. We'll study processor in very details in like 8 modules, and module 9 is dedicated for the memory systems. Okay. What else is there? There is a link for the online class recording that we are making here. I have the link to my YouTube channel for the classroom. We have the Zoom registration page and also whiteboard link. This whiteboard link will bring you to this page, where this is mainly I use for the discussion session. If I need to draw the diagram to explain something, so I use that. So make sure you can visit that. You have access to that one to view it. And the Zoom registration, let me go to that page a little bit to share with you. So one important point is that you need to register for this class, and once you get that registration, like approval email, that will have the link and meeting ID and everything, make sure you keep that email with you. Don't move it to the trash, because we'll use the same link and same meeting ID throughout the semester. And you don't need to register multiple times for each day's session. Just once you register, that's it. And you are done. And you keep that email with you. Why it is important? Right now, the registration approval has been made automatic. So system will automatically approve anyone who is trying to register and do so. So after the class list is settled down, I will change that automatic approval to the manual approval. That means if you try to register at that point, then you basically will need to wait for my approval to join you. So don't wait for that. I think Canvas, I don't know if they have changed the integration, but Canvas integration, if you go through the Canvas link in the Zoom page and that link, it basically will bring you to the registration page every time. So don't use that. Just make sure you keep that Zoom meeting ID handy with you, save that email, and use that link throughout the semester. So once you register, you don't need to register one again. Is that clear for everyone? All right. Now, what else I have? This is the Zoom page link, etc. Okay, let registration and add code. Like if you have the late registration, I don't think any of you need add code. Right now, the system is built up such a way, if there is a room in the class, it will just automatically send you register in the class. But if you have registered on or after August 19, that means you are a late registered student. In that case, please send me an email with the subject line late registration request with your name, student ID, and SJSU registered email, so that I can send you back the prerequisite survey link. So that is very important thing that you need to fill out and upload your transcript for your prerequisite proof. So make sure you do that if you are late registered student and you haven't received yet prerequisite survey link. Make sense? Okay. Now next is this is the page. Everything you need to know is this page is basically, I would like you to review all this video. There are 5 videos. Course introduction with the logistic. This is very important. You know the timings, office hour, etc., etc. Then the protocol, another important thing that you must follow certain protocol in this class. Navigation is the more details about the where is what in the Canvas page. Challenges, this is probably the most important thing. It explains what are the challenges you are going to face and how to mitigate them. Mostly this is a flipped style class. That means all my video, all my lectures are pre-recorded and already available through the Canvas. And all the lecture notes are available in the Canvas. So what all you need to do, you need to be prepared before coming to the class session, review those videos, review those lecture notes, then come to the class. In the class, I won't be lecturing. In the class, we expect to have a discussion session with you. Just imagine this class as a extended office hours. So you come with your questions, come with, if you have any doubt, you need to clear your concept or anything, that it will become more like a student-led session than a teacher-led session. So you lead the session and we go into the discussion, we go into the problem solving and etc. So it will be more like interactive session than just a lecturing session. So that's very important. I think for many of you, it will be a paradigm change where you go in a class, listen to the lectures, then go back and do your study and all this stuff. It is not like this. You basically listen to the lecture up front, then come to the class for the discussion. And then you clear up your concept. Then if you need to go back and revisit, you can go and revisit things. While I'm on the video subject, let me also point out one thing. You will notice that those video lectures are recorded quite like 2-3 years back, I think 2018 or 19, something like that. You will be wondering, hey, why I am like starting this old thing? Why this is 2021? Why you are learning the old things? Because, you know, like the fundamentals of computer architecture haven't changed for 60 to 80 years. Like what was there, von Neumann architecture, Howard architecture, it is still there fundamentally. So here in this course, we are trying to catch up with those fundamental concepts, which is already there for many, many years. So nothing new. New things happens around that. Once you know the concept, we'll touch base some of them in the parallel architecture, touch base a little bit on the cache and caching architecture and the, what is that called? Virtual memory system, etc. Like more new things actually are part of the master study, not the bachelor study. Bachelor level, you are supposed to know the fundamentals of the computer architecture, which is a very established thing for last 60 to 80 years. And you'll see, like, for example, like even like we are based on a very fundamental mathematical model of Boolean algebra, which has been there from 1940s. And this is very fundamental for computer systems, right? So it is not that everything is very dynamic in computer science field. Probably most of the studies you are doing, language studies and all these new language that you are learning, you will have that perception that it is very dynamic and every 2 years things change. Like this year it's a year of Java, next year it's a year of Python, and this and that, all these new technologies are coming up. Those are all at the peripheral software application levels. Fundamental core still remains the same. It hasn't changed for a long time. What has been changed? What is new? Quantum computing. That's the new thing. And that's beyond our scope of discussion in this class. So we are still not studying quantum computing. We are still studying the fundamental basic silicon-based computer system. All right. So that's the reason you will see these lectures and notes are not changed that much since I have created them. Okay. Question. Okay, all right. Now, what else? So you will see a lot of logistics are also placed here. Mainly you see you have to complete these 3 activities. Initially, please make sure you are done with them. Also syllabus. Okay, this is one thing that I want to show you. Of course, it has a green sheet and you can review the one that is there. But here is the course summary, how to use them. For example, you are coming to Wednesday, August 25th, right? This class. Before that, you see you have some to-dos. So I have marked some pages as a to-dos. That means this is a guideline for you to follow, that before 25th, you need to finish up these 4 things before coming to the class. So what are the 4 things? Introduction to module 1. So this is a module introductions page and laid out in a very similar way for each of the module. So it basically gives you the introduction of this module, what we are trying to do in this module, what is the objective and goal, etc., etc. It may have some optional videos that I would like you to watch at your spare time. And then it basically describes those objectives, and it has a link to the QA. This is practically your Canvas discussion page for that module, so that you can put your questions there and someone, your friends or myself, can answer that, try to explain, put it in a discussion, etc. That we can do. Assignment, it has some assignment marked for this module, but this assignment may span across the module. Means project 1 may not be just related to the module 1. Maybe it is related to module 1, 2, and 3. But it is somewhat given to you, project 1 and 2. Assessment quiz 1 is also like, it can span multi-module. It is not related to just this module, but quiz 1 has part of the module 1. That's what it says. And you will see some practice problem set also on this lecture 1, 2, 3, etc. So I would suggest that you go and try it yourself first. And if you go in the module page directly, you will see there is a solution also. Yeah, there's a link to the solution also for the problem. So I would suggest not to jump into the solution, look at the solution right away. Try to solve the problem yourself first, and then look at the solution. Where do you need this problem and solution? During the exam, final and midterm exam, it has included problems to solve in this thing. Quizzes has some problem, but smaller subset of this type of problem. It's a smaller subset problem. Okay, so that's the one thing I want to cover with you on this. What else? All right. Joshua, you have this question. Did I answer your question over email?
We talked for a bit, but not 100%. You just said to come to the first day of class.
Oh, okay. So you are a CS major, or?
No, I'm a math major trying to switch to a CS major, and I needed an upper div to meet the requirements.
Okay, and you have this prerequisite of CS47. You completed?
Yes, I have the prerequisite.
Okay. Okay, I probably talked to the department chair on that. I need to dig up my email. You already said, okay, let me walk you through, okay?
Okay.
So you need an add code, basically. That's what you are saying. Did you send me the email that I said?
Yes, yeah, I sent the email.
You did. Okay, okay. All right. We'll go from there. Don't worry. Okay. Now, what I want to do. Oh, office hours. Office hours. So for the office hours, what you need to do, you can go to the calendar. And for this course calendar, you should be able to find out a slot, like 4:30 to 4:45, like 15-minute slot. So you can go and see if the slot is available. You can reserve for that day. If you click on that or reserve that, you will see there is a Zoom link. You can use that to come into the office hours and talk to me. Okay, so please make sure you reserve the slot. So it is each Monday and Wednesday from 4:30 to 5:45 p.m. That's what the slots are. Okay. All right. Now, we touched base about the study process. Yeah, please make sure that you review all the videos before you start even in the course. You know what to do in the course, how to proceed in the course, and how to study, excuse me, in this course. Okay, let me do a little quick polling to see where are we. Let me see what is the poll. I have like 6 questions for you. So please make sure you answer it truthfully, and I think you can take it anonymously if you choose to. Let me launch it. Let's take like a minute and a half probably for the 6th question, and I will share the result with you. So here it goes. Okay, we have 25 out of 28 participate. I'll wait a couple of more seconds. Okay, we have all the 100% participation. Let me end the poll and share the results with you. What it looks like. Early registered student is 22 out of 28. Late register is okay, and not yet registered 4. So for late registration and not yet registered, please send me that email that I showed you, like the subject line that late registration or add code, and you just give me your name, student ID, and email, SJSU email ID. All right. And what I'll do, I will send you back a prerequisite survey on that so that you can complete, and then I can check your prerequisites on them. Have you taken class from this teacher before? Okay, 32% says yes, 68% no. That means majority of the class is haven't taken class from me. Okay, so I will set up the study group accordingly. Seems like. Which assembly language you're familiar with? Okay, ARM 1. Okay, MIPS 32%, 9 of them. x86 Intel is 46%. Yeah, that I expected. Like, I think many of the community colleges and other university teaches x86 and very core assembly language there. Okay, 2 of you guys said others. Can you guys tell me what are the other processor you experienced? Someone marked others. No? Okay. All right. And I think one of you or four of you said don't know assembly languages. So how did you guys do the CS47 or equivalent course without an assembly language? Do you want to explain that? Though this is not an assembly language class and it is not heavily weigh on the assembly language, but the importance of these, you need to know the construct and basics of the assembly language so that you can build up a processor on a given assembly language specification. We'll do exactly that in our project. We'll come up with a made up assembly language. It's more towards a MIPS style language. And then we will build a hardware system which supports that assembly language. So you need to be familiar with the concept of the assembly language. So whoever has given that don't know assembly language, please make sure you have the right prerequisite with you. All right. Do you know how to convert assembly instruction to machine code? 57% said yes, 43% said no. For those 43%, it is very important that you follow up lecture 1, I think lecture 1 and 2 very closely, okay? I expect you guys to actually have very ease on this concept of assembly instruction to the machine code conversion and vice versa. Are you familiar with a digital design using logic gate? 43% said yes, 57% said no. Yes, someone want to say something? No? Okay, so that means, yes, Matthew, you wanted to say something? Chien, your voice is really...
Is it me or somebody also here kind of not clear?
Yeah.
I think his internet died on him.
Okay. Because it looks like he's in a car. So
Yeah.
okay.
No? I don't hear any humming noise. It's just Chien, you wanted to say something, but your voice is really bad. Like it's breaking up. Almost like a level to the noise. It's coming as a noise. Okay, let me get back to this. Number 5 question. How do you familiar with digital design using logic gate? Very important concept. So whoever don't know, these first 4 modules is very important. And make sure you pair up with one of my former veteran students to go through these chapters very quickly and pick up those concepts. Are you familiar with the K-map? Again, similar distribution, 3961. We'll again revisit that in this course, but we'll go through it very quickly. So this will be, you need to catch up, all right? You need to catch up on this part.
Professor?
Yes, Rahul.
Digital design using logic gates. Is that what we did last semester? I thought it was hardware design using logic gate.
They're the same. They're the logic gates, right? You use
okay, this making stuff out of logic gates, making the ALU and stuff.
Exactly. We did that.
Okay, that's what you're referring to. Got it.
Yep.
Thank you.
Okay. All right. Now let's quickly do some group activities. So here, I will open a breakout room randomly assigned. So let's discuss this. Why don't you guys discuss among yourself? And I'll try to visit 1 or 2 rooms in the meantime. First of all, how was the summer break? discussion topics, your initial impression about this class, include both your liking and room for improvement, and special focus on the challenges that you may be anticipating through student feedback, internet feedback over internet, and so on and so forth, and indicate if you are already a taken class from me, if you are a veteran student from me. All right. So I will allot probably 20-minute time to discuss, just get familiar with yourself, with others, maybe in a small group, and then we'll be back in the main session. And let us see if we can wrap it up quickly after that. Okay, so here, breakout. Where is the breakout room? Here. How many participate? We have 28, 4, okay, 7 breakout room. Create, almost like that. Okay, option, 20-minute.
Professor,
Yes.
is this the only section you have for CS147?
I am taking only one section. I think there are other teachers who is taking CS147 as well.
Ah, I see. Got it.
Okay. Okay, I think, yeah, I visited a couple of rooms and meet you guys more kind of in person. It's really virtual, all of you. Yeah, so let me know if you have any questions at this point.
Can I have one question about the deadline? So what are the next steps that we need to take? So you have mentioned the prerequisites and any further assignments that we need to be aware of, because I missed like the first 3 minutes.
No, really, the prerequisite survey, that is the important one. Other than that, everything is flexible, and nothing is, no other deadline before the last date of adding courses. I think last date is, as far as I remember, it is September 8th, I believe.
Mm-hmm.
That is the last day to add any course. Okay, so no deadline before that, at least.
Okay.
Okay, so don't worry, just send me the email and we'll roll from there.
Okay, thank you.
All right. Okay, so let's quickly look at what is upcoming next day, and then we can wrap up things. Before go to that, just make sure whoever got this prerequisite survey, please make sure to done it by August 25th. And I will go through them, and if there is any discrepancy, any question I have, I'll contact you. Otherwise, you are good. So in most of the cases, you are good. If I have any question, it is not end of the world. Just I'll work with you through the whole process. Okay, and also before coming to the next class, make sure you already reviewed those lectures and videos. And Thomas, if you don't have Canvas access till then, you can go to the YouTube channel and have those video reviewed. Okay, so it has this lecture 2 videos.
Okay, thank you.
I'll send you a link if you cannot find it. Let me know.
Okay, thank
All right.
you.
Okay, so let me just share once more. Screen share. Okay. Okay, so again, we go to the syllabus and see what is upcoming. August 24, these 2 introduction page to those modules, please make sure you go with that. We have 2 parts of the class always. One is the theoretical study, other is the lab. Lab is important in the sense that I will give you some small teaching about the Verilog language and our tool setup for this course. So and you need them to complete the projects. No exam will be coming up from the lab. Like exam question doesn't include the lab session or anything. This is just for your learning and apply that in the project. Theoretical study is that one which actually included in the exam and quizzes. So let's look at them one by one. So lecture 1, computer system and instruction set and ALU. This is kind of a very speedy overview of CS147 and related things. So what we'll do here, we will try to define what is a computer, and we try to come up with a model of the computer, and then we make an instruction set. So you already know program through the assembly language x86 or ARM or anything else. So what you do is basically consult an instruction set where all the instructions are listed, what they work, what they use for, etc. So we'll go a little bit deeper concept on that, what is an instruction set really means. And from there, we'll try to come up with a made-up instruction set for this class. So this is not tied to any process or anything. This is just an abstract concept where we do these instruction set definitions, and from there, list of instructions that we are going to support, what is the operation, what is the opcode, etc., and how to convert them from an instructions to the machine code and vice versa, those kind of concepts. I expect that you guys kind of know that already from your 47 or equivalent classes. If not, please make sure you are up to the speed on these concepts. So these are all the instruction, and we will be using this instruction set to build up our processor in our project. Project 2, project 3, all about building a processor at the different abstraction level, oriented mainly towards this instruction set. So please make sure you understand each of these instructions very thoroughly, because that understanding you need to carry on to define the hardware. So make sure you understand this part very deeply. Okay, so once we have done it, then we will come to revisit that different part of a processor. We start with the ALU, see what they do, what is the ALU, and etc. This is more like a review of those concepts that we have been taught in the CS47 or equivalent classes, or should have been taught. So we'll start with the ALU, and we'll continue our study in the lecture 2 about other components as well, like a controller, like the memory system and all this stuff. So these are the abstract concept modeling. That's the part of the lecture 2. That's the end of the lecture 2. This is a note, and you have the videos. We have like 3-part videos. What is a computer? And then I describe this CS147 DV instruction set. This more look alike the MIPS instruction set. So whoever has done the MIPS programming, they probably can relate a little bit more, but don't worry if you are coming from x86 Intel family of assembly language, just pick up. This is all like a basic concept of the assembly language. That's it. So we are defining the instruction set there. And then the part 3 is our arithmetic and logic unit. It's abstraction model, and what it does, that's what we try to understand here. Use this link to ask question. It will bring you to the discussion page, and you can put your question there so that I can immediately answer that, or some of your friends can answer that on your question, so that you can study uninterruptedly, I would say. All right. The other part, the Verilog module, what is that content? Let me just go there. Page setup is similar, lab 1. So it has a video, so watch it. And there is a lab node. This is just a note for those slides, basically, nothing else, nothing theory. So for this lab, we are trying to set up your environment, project environment, mainly the tool called Model Sim. But this video is older video. It basically talks about going to the Mentor Graphics, which is now Siemens, acquired by Siemens. And after this Mentor is acquired by Siemens, legal things get really complicated, and they are no longer providing a student direct edition for the simulator. So we have the other Intel route to establish your simulator. So make sure you pay special attention to this node. If you click on that, you need to follow this part. It has quite a lot of different discussion that probably you need to know, or if you have faced that challenge, you can come to this page and have your challenge answered. But this is the main one, like Model Sim installation from Intel Quadras Prime integration. So this is the steps you need to follow. Please make sure you follow this step and install the tool at your environment. All right. And I have one more videos there. This is another alternate tool to the Model Sim tool. It is the ISE Webpack from the Xilinx. One of the advantages that I'm sure that this can be installed on the Linux platform. But challenge is that all my discussion and lab tips and etc. are based on the models. So it will be really advantageous if you can use Model Sim, but somehow if you want to have another alternate tool, Xilinx ISE Webpack would be another way for you to try out. All right. So please make sure lecture 1, lab 1, you finish them up. before coming to next class, and then we'll do discussion in the next class about this concept, and any queries that you have, you can ask me. So, but remember, there is nothing called a stupid question in the class. Like every question is important. Every question is fantastic question. And you need to ask a lot of questions in order to make this concept clear. This is not a very trivial for computer science student. All right. It is a very different subject than the rest of the computer science study. Question? Okay, then let's wrap it up tonight and see you all on Wednesday. Good night, everybody.
Thank you.